Hello, everyone. Thanks for joining us today and welcome to our virtual meetup. And I'm glad to introduce the speaker of our virtual meetup. Courtney Robinson, CEO of Hypi. He is Apache Ignite enthusiast and actively participates in community events. He is a speaker of the first Ignite Summit and a committee member of the upcoming Ignite Summit Cloud Edition. So, Courtney, I give the floor to you.
Thank you, Evgenia. Welcome, everyone. And so today's meetup, what I'm going to try and do is share to you a little bit about our experience with working with Ignite from the company's perspective and kind of the journey that we've been on for the last 3+ years of trying to get everything going from when the idea was first started through to production and the versions that we've iterated on since then. My name's Courtney, as was introduced, and I'm co-founder and CEO of Hippie. Hippie is a low-code and no-code backend as a service platform. And at the center of our platform is Apache Ignite and a number of other technologies, which I'll get into later. As mentioned at the start as well, the Ignite Summit is coming up in November. It is free to attend, so feel free to register and join that event. If you've got an interesting story that you'd like to tell, the event is focused on cloud kind of use cases. So if you're deploying into Kubernetes, AWS, or other kind of cloud environments, then submit your talk and get a chance to basically present your use case at the Ignite Summit later this year. All right, so I'll start with providing a little bit of background, just talking about what Hippie is. I mentioned that it's a low, no-code and backend as a service platform, and it has those three separate titles for some of you that might know, because we started from providing a backend as a service platform and have basically built other services on top of that. So at the moment, what's live in production now is the backend as a service. That's what our customers currently use, and that's the service that we currently provide. In November, what we're launching is our no-code drag and drop that will enable basically non-technical, non-developer users to start using the platform to create native mobile and web applications without writing any code. The other thing that's coming in November is our marketplace that allows our community members to basically create modules or libraries that extend the platform and sell and buy those to use in your applications. So if you're building, for example, a new application, some of them will have a login screen, for example. There's no need to build that every time. You'll be able to just go into the marketplace, grab a login screen, add it into your app. So that's all coming up later in this year. And what I'll talk to you about today is the architecture we have in place now and the architecture that we're working on to be able to support a lot of these new features that we're adding to the platform as it's maturing. So a lot of the applications that you'll come across will typically fall into two categories. They're either kind of offline, self-contained, and requires no external services. But the vast majority of applications are in some way data-driven. They get the data that they use to decide how to behave from some source, right? Whether it's a database, an external service, API, or something like that. And Hippie strictly focuses on data-driven applications. And these can fall into any kind of category, use cases from banking to healthcare to social, whatever you can think of. There's probably some data behind those common applications that you know and love. And what Hippie does is, at the moment with the backend as a service platform, it basically provides a service that speeds up the typical development lifecycle for a developer. So the common things that you would effectively end up having to build all the time, Hippie automates some of those. And in a traditional kind of development lifecycle. When you're building the service that powers one of these applications, you'll typically put some API service in front of potentially some more internal services, things like authorization, a database, and whatever else you need to provide the service that your customers derive value from. And then you might have some external integration as well. What Hippie does is we effectively take a lot of that onto our side. So in the traditional workflow that I just described, you would effectively have to work through and implement a lot of the things that you see on screen here. So development, from the client perspective, you'd have to create your mobile apps, potentially separate web app, and in some cases where some people would build the iOS and Android app separately, you have different code bases, right? Then you'd need all the supporting services. You'd need to have things for managing deployments, monitoring, metrics, and the ongoing maintenance, and extending that to provide new services as additional use cases come up for the business, right? What Hippie does is it takes a lot of the common functionality and it provides those out of the box. So, for example, the database that you might need for storage, that's already built into the service the platform provides. You don't have to worry about, which database do I provision, how do I manage, scale, maintain it, and so on. That comes built in as part of the service that's provided. The other thing that we include is authorization and authentication. So if you have an application that requires users to be able to say, I'm going to log in, then you don't need to rebuild that every time. When you use the Hippie platform, that's all part of the service that you get, right? So what you end up doing is, instead of communicating with your external with your manually developed service, then you would point your application at a Hippie provided endpoint. And this is available both on-premise and as a cloud option. So we bring all of those things into the platform, and even interacting with external services, you can still go to them directly, but Hippie provides an API gateway that allows you to basically apply things like authorization, etc., to the external services if they haven't got that functionality built in, and you just use the Hippie, the one Hippie API to manage all of that. What this means is that from a development perspective, what you end up focusing on is only the client aspect of the application. So you would focus your development time on the mobile app, the web app, and again, if you split out iOS and Android development, those are the things that you would work on. What Hippie then provides is everything else from 2 or 3 slides ago, where deployment, monitoring, tracing, login, metrics, all of those things are built into the platform. Maintenance and all those things, you manage them yourself, but they are done through the platform and through basically clicking, right? So there's no longer a need for you to write code to say, for example, we need to go find out what service is being slow, or put in additional metrics. You can just go into the platform, use the user interface, and add in whatever you need to be able to work out what you're trying to find. And importantly, things like database authorization, all of that is already included in the platform. So how do we do all of that, right? And the reason we're here today is because at the center of the platform is Apache Ignite. And that's what I'm going to talk to you about and walk you through kind of the evolution of where we've been coming from with Ignite. At the center of our platform, we started out being very GraphQL centric, and to this day we still are. Although we've added support for REST and other protocols over the years, at the center of the platform is our GraphQL engine that pretty much everything else will translate to. And when we first started with Apache Ignite, we started by using the key value API, and this basically enabled us to be able to provide a custom cache store. And there are a number of reasons why we ended up doing this. So we'd already had a product with data, etc., before we adopted Ignite. And so when we migrated, we kept the RocksDB that we were using to store data beforehand, and then we just put Ignite on top of it. And so the architecture at the time meant that what we would do is we would have the key value API, that was the public facing API we would use in our application. And then when we tried to get data out of it, we would have a custom Affinity function that would work out which Ignite node has that data, and it would then basically do the routing, go fetch that data, and go down to the RocksDB store. We also had a very rich query language to be able to find data that was built on top of Lucene. And because at the time, the Lucene capabilities that Ignite provided wasn't sufficient to match what we needed for the application, as well as running the keeping the RocksDB cache store, we also brought in our Lucene implementation that had our indices from before. So we brought both of our storage options over, and we just layered Ignite on top of it. What we then did was we implemented a number of capabilities that brought these two together. So we were making heavy use of the Affinity run. So when we tried to do a compute, for example, to get data for a particular client's application, we would have some Affinity function that would run some compute job on the right node based on hashing that would happen to identify where that data is stored. On top of all of this, we effectively implemented a distributed query engine. And a lot of that was powered by the nature of GraphQL. So the way we implemented that, the way it actually worked was largely determined by what the GraphQL engine needed. But effectively, we'd implemented a distributed query engine that encapsulated authorization. So if you wanted to access data, all of that would be authorized properly, right? And all of that was implemented on top of the existing key value APIs. And what we found when we initially went to production with this was that even though the performance was very good, we had difficulty with some of the queries we were trying to express with purely the key value APIs. And so we ended up looking into a few data structures that we could use to try and do some types of traversals to answer some of the queries we needed. And that's where we looked into what's called an FM index. An FM index allowed us to effectively run graph queries. So if we wanted to know the connection between A and B, or if there was a connection between A and B, we could use the FM index to be able to find that data. And it also served a double purpose of providing compression for some of the lookups that we needed to be able to do. And alongside that, we had serverless, which is how, if you're implementing your application on top of the platform, that's how you would provide custom behavior in your application. So we would provide things like CRUD, authorization, etc., and then you would use serverless functions to add additional APIs, additional functionality that your application might need. Now, this worked well, and not that one. This worked well, but what we eventually found was that because we'd effectively just picked up what we had before and moved and put Ignite on top of it, we started running into a number of issues, as you might expect, right? And so we evolved the architecture to meet those requirements. And I'll explain a little bit about what those requirements are as we go through. I'll go through them one at a time. Now, another part of this architecture, or rather the way this worked top down, was that when you needed a piece of data, if you're not familiar with how this works in Ignite, you have what's called an affinity function. And the affinity function, effectively, when you say, oh, I'd like key X, it will basically return a hash that tells Ignite, okay, the data is available on this particular node in the cluster. And because we effectively carried over our Lucene and RocksDB index, we use this to identify where these were, and the clustering for this was done on the ID of the customer. I'm trying to recall how exactly this was done. This was 3 years ago when we originally did this. But basically the ID for that cluster's instance was the common denominator that determined where in the cluster their index and their RocksDB database was held. Now, it worked and it scaled well. And what we found was that as we'd started to grow, the use cases also started to grow. And with that came new queries that we were starting to struggle to express with the key value API. or rather, when we needed to express those queries, it would take us a significant amount of time to think about how we implement them and then map that requirement onto the key value APIs. So the more complex the queries became, the more time we spent thinking about how exactly we needed to do that for it to work and serve the right data effectively and maintain the low latency that was needed for our customers. So in the end, we'd gotten to the point where we'd effectively implemented hash join and merge join over the key value APIs in our applications, because as the platform was maturing, use cases were growing, those were the queries that we needed to be able to serve the data that our customers needed. And if you know how some SQL databases work, you'd realize that we'd effectively re-implemented parts of a SQL database, right? When you're doing join queries in SQL, depending on your queries, you might end up having a hash join or a merge join or another type of join being done by the database. And we'd effectively implemented that, except it was in our application rather than in the database itself. And so we made a decision that we'd gotten to the point where we needed to start looking at using the SQL APIs. And if you know the Ignite SQL APIs, one huge caveat we had with it at the time was that we would lose support for transactions. And it was we had to sacrifice transactions in order to get that, because the platform was maturing at a speed that we wouldn't be able to keep maintaining and growing this without significant effort on our part. So we decided that the transactions weren't worth it, and we effectively decided to move to SQL and abandon the parts that we effectively re-implement from what the database should be doing. And Ignite itself implements things like hash joins, etc., from the SQL perspective. So there's really no need for us to be implementing those things again. We had no business implementing those things again. And so we decided to move to SQL, but that was in architecture. It was a huge decision to make, and eventually we did move that away. And there was also another motivating factor for this. One of the things that we'd started to notice was that our query times were increasing. And that last point I have in the bullet points here, we'd gotten to the point where our queries were so complex that roughly around 35% of the time of our queries were actually being spent on Lucene. Not just Lucene, but everything associated with getting to Lucene, getting the data back, and then actually going to Ignite to pull those keys out. And that was only increasing kind of every 2 or 3 months. And so we saw the writing on the wall that effectively that was no longer a viable strategy. So that was also a motivating factor for why we eventually migrated. And so we got to a V2 architecture, if you will. And this is actually not the latest, but it's the latest diagram I could find of what the V2 architecture looks like. But it's evolved a lot since then. This was one of the originals. By the time we'd gotten to V2, we had support for 4 or 5 different ways for customers to get data into the cluster. We'd added support for streaming, so Pulsar, Kafka, I forgot what the other one was that we had at the time. We'd added a REST API, we'd added support for file uploads, and support for real-time subscriptions on the data. So if you're a customer building an application and you wanted to build, let's say, for example, a WhatsApp messenger, right? And when someone sends a message, you need whoever is in a group or the recipient of that message to receive it more or less straight away. That WebSocket support that we added would enable you to be able to do that without building any of the infrastructure it would typically take for you to be able to implement a feature like that in your application. And so the input sources had grown, the overall use cases had grown, and the functionality, pretty much everything about the platform had matured. So the architecture that you see on screen enabled us to move to the SQL APIs on top of Ignite, and we still had to keep Lucene because the SQL support that we were moving to still didn't provide full text index, or at least nowhere near to the capabilities that we already have providing to our customers in the platform. And if you know full text, almost nothing that I can think of really compares to what Lucene provides. And so we kept Lucene, and we then combined Lucene with Ignite SQL and Ignite Compute to provide the capabilities that we needed. But what that meant moving to SQL was that more of our time was spent on implementing the platform capabilities and less trying to manage how we work with and get data in and out of Ignite efficiently. So the move was definitely worth it. And not long after, we came to the realization that it had its own downsides. It's something that we knew before going in, but certainly there were things that we couldn't have anticipated that we started to learn as we'd gone to production with this. And like I said, these were things that came out after going to production. So while we were in testing, they weren't a problem. They didn't show up, right? So we started to basically take note of what those things were. The biggest one we have actually with SQL, and to this day it remains a problem, is the inability to change the data type just to something random. There is limited amount of change that you can make with data types, and what we had originally, because the key value APIs, the binary APIs, you can just do whatever you want. We were allowing customers to be able to change the types of their fields. So they would define a model and we would map those to Ignite caches, right? And the flexibility that the key value API provided was somewhat less when we moved to the SQL API. And that remains a challenge to this day. And you'll see when I get to what we're currently building, how we're solving that problem. That remains the biggest sticking point. All the other issues that we came across, we kind of solved over time. The architecture itself ended up pushing more onto the Ignite side of things. So we were doing kind of less about how we get how we query Ignite, how we get data in and out of it, and more of I guess the platform's features just simply running a SQL query that matched what the customer needed. One of the challenges we have for our particular platform is that we're generating these queries dynamically. So a customer can come in and they can arbitrarily decide that they want to create two models and then link them however they'd like. And as they decide, okay, I would like to query my data in this way, we are generating the SQL queries that are effectively providing that service to them. And so we don't have the kind of control that you might have if we were doing this by hand, right? You could say, all right, we know that this is what our schema is going to look like. This is what the relationships are going to look like. And we can then do particular optimizations to match whatever that SQL model might look like. But not knowing what your model looks like, we have to just work this out on the fly. And we provide the tools to customers to be able to say, all right, look, if you're going to be querying on these particular fields very often, then you should use this feature of the platform, for example, to provide an index. Otherwise, you're going to start noticing slowdowns in your application as the data grows, etc. But a lot of the users that we have, because of the ease that the platform allows them to build with, rather than mid-level or senior engineers, once it's been adopted into an organization, it tends to be like interns or less experienced developers that work with it. So many of them don't know what an index is or why they should do it, that kind of thing. And the expectation for that knowledge to exist kind of just went away as the platform has matured. So we can't expect customers anymore to know that they should add an index on a particular field. And that's one of the interesting learnings from moving to this architecture and providing the service that we do. So making this move basically solved the complex query problem. It completely solved that problem, and it continued to scale well. We did notice that our query times had like around 15% increase in latency just across the board, which we'd narrowed down to the SQL queries. It was basically taking about 15% longer to be able to answer those. And there were a number of factors for them. Again, it basically came down to the fact that we don't know what these queries are in advance, although we kind of know what the patterns are in some cases, and we've provided more and more optimizations over time. We really don't know at development time what customers might want to know about their data, and so there's no real solving that at the moment. So we put that to one side because 15% isn't that bad, to be honest. So the trade-off of basically losing transactions to get this better better API to be able to do queries with was definitely worth it. And as I said, we continued to learn that there were a couple of things that we needed to adjust to then work better with the SQL APIs. The one that we still haven't solved is the data types that we allow customers to just arbitrarily change. Now, we're at a point where we're looking to basically implement version 3, version 3 of our platform. And what we've been doing for the last couple of months is largely still research. So we haven't actually delved into this in earnest yet. We're still in the research phases of this. We've done a number of experiments with kind of like production level workloads, etc. But largely, this is still early days for this architecture. Now, what we've decided to do, one of the things that we've learned is that the data sources that we need to support are just ever increasing. And so one of the capabilities we've added to the platform is the ability for customers themselves to add their own data sources, because the more use cases we looked at just when we had like case studies with our customers, the more we realized that we didn't support anywhere near enough data sources to cover all of them. And so we added the platform, we added the capability to the platform for them to be able to add their own data sources. And that meant we've changed some of the terminology and the way we present these to customers. So we've shifted to the whole terminology of now talking about sources and sinks for your data. Basically, a source is where the data is coming from, and a sink is where you're going to put it. And that can be one and the same. Like Ignite in this architecture is both a source and a sink. And I'll come on to a little bit more about that shortly. So we, at the moment, have decided a couple of things. The first one is that the move to SQL was actually very good for us. It simplified a lot of the things that we were doing internally in our application, and it allowed us to focus on other parts of the platform. So instead of us basically re-implementing things that a database would normally do, we can now focus on what adds value to the platform. And in the next version of the platform, we've decided to keep SQL, but not directly using Ignite SQL. Instead, we've adopted Apache Calcite, which is basically a SQL query engine. So you get the parser plus the query engine, if you know the distinction between the two. And at the center of this new platform is a calcite facade that we're working on. And what this means is that when you're using the platform, so if your data source is Ignite, it won't just go directly to Ignite with some SQL that we've generated. It will first hit our SQL, our calcite SQL facade. And this provides a number of benefits, right? The main one is that one of the patterns that's evolved, if you're familiar with the no-code and low-code space, one of the big problems most customers find is that as their application matures, a lot of these no and low-code platforms, they just don't scale. And Hippie is different because we came at the problem from a completely different angle. We started with scalability first, and so we had a scalable backend as a service to begin with. So that doesn't apply to us. But it's a very common problem with the typical no-code, low-code platforms. Now, with our calcite facade, what we found, over time, what we found was that the apps that were being built had such a diverse set of data sources and sinks that there was no way we would effectively support all of these use cases as a single company. But more importantly, customers wanted to be able to pull data from all of these sources, work with all of them, as if they were just one giant data source. And in some cases where that applies, performance isn't the most important thing, or scalability isn't the most important thing for some of those customers. Just the ability to work with all of their data sources in one place is super important. And so that was one of the driving factors behind the calcite integration into the platform. What calcite allows us to do is to effectively treat it as a data virtualization layer. And if you're familiar with the term, then you know what I mean. So for those not familiar, basically, instead of directly hitting one of our data sources like Ignite or Oracle or something else, we'll have a data virtualization layer, basically a service that sits in the middle of our query and says, hey, this part of the query needs to go to Postgres, this part needs to go to Oracle, and then bring all the results back together, filter it out depending on whatever the user has asked for, and then just provide the end result. So from a user perspective, you're issuing one query, but the actual data itself can come from n number of sources. And the majority of cases we have with this, they don't particularly care about performance because some of those data sources are inherently slow. What we've done, though, is we've taken calcite, placed that in the middle of our platform. We've taken Ignite, placed that next to it, and taken Solar. And we have these three that form the core of the SQL facade. Now, the way they work together is basically the calcite query engine will say, hey, we'd like to get this batch of data that matches this particular query. We'll send that off not directly to the data source, but first querying Solar to find out if that data has been hit and indexed before, right? And the side effect of this is that as more of the external or internal sources get cached into Solar, the queries that would otherwise take a particularly long time to come back, they start coming back in sub 50 milliseconds across the board for your entire query. And regardless of the type of source, so whether it's some HTTP API or an external database or whatever, what we're doing is on the fly deciding to cache some of that data and index it, depending on the properties that the users are providing. So we're enabling users to say how they would like these syncs, or rather sources, to be indexed. So we're not just arbitrarily picking and indexing everything. The users will sit down and they'll create a model, and in that model they'll say, all right, I would like to join my data from this random source to this other random source, and implicitly that tells us where we need to start looking at creating indices automatically. But importantly, we've basically come up with a simple UI that, without saying, hey, you need to create an index for this thing, we guide them through the process of effectively telling us how we should index the data from these potential databases or other kinds of sources. And what that's meant in our implementation so far is that even arbitrary APIs that would take half a second on their own, the entire query is being returned in under 100 milliseconds, which is our target for our end-to-end responses on our APIs. And we've built out support for the ones that I've got listed on screen here. These are the ones that we're going to support and maintain in the platform. But I mentioned marketplace earlier. We're allowing customers to effectively define their own custom sources and syncs. And now the other part of this that this architecture really solves, and a huge part of it, is the virtual catalog. I mentioned the problem we had earlier of the customer's inability to change data type to some arbitrary thing type. So they can't just go, I would like to change my current string column to a numeric column, because that's not supported by most databases, I think. But it's a feature that most customers would like to have. They've created a model. At some point, they realize, actually, that was a mistake. I would like to do this instead. And we'd like to provide them the ability to be able to change that. And that's one of the key things that the virtual catalog in this diagram actually solves. So instead of directly mapping from the user's name, so we allow them to create a model. Let's say they wanted to, I use the WhatsApp example again. So you want to create a message type. And in that message, you want to say you have a field called text, and text is of type varchar or string. Now, instead of directly mapping text to a column name in Ignite, the virtual catalog basically maintains the mapping from the user's name to what the actual column name is called. What that means is if the customer decides, hey, I would like my column to have a different name, we're basically saying, all right, cool, but your type is currently a string and you're trying to change it to an integer. So in order to do that, you're going to have to tell us how we convert the existing column over to your new data type. And they provide a function that we then apply to their data, and that will do the conversion. In the meantime, they can do that conversion. New data can go into the table with that virtual mapping that's just rerouted and pointed the old column over to the new column of their new type. But that's the architecture that we're currently working on. And at the center of this, one of the key things I mentioned earlier we provide is authorization. So we've switched from what was basically a synchronous request response model, where you'd get a GraphQL query, we'd take that, query the database, query whatever, and get the results back, send it straight back. That has now moved to messaging API. And that's largely because of the sources and syncs that we need to support. It doesn't work for many cases. And it has its challenges in making it scale and also in protecting the platform itself, because you do occasionally get customers that even if not intentionally, they can abuse the platform, right? And we're basically doing this to be able to protect the rest of the platform from a customer that's either gone rogue, whether it's intentional or not, from themselves, and to prevent other customers from being affected by this rogue behavior. And so switching to a message based approach has enabled us to effectively more easily build in things like rate limiting, which I think just from our testing so far is working out to be better for a number of reasons. So one of the side effects of this has been that we no longer need to worry about the memory and management of our threads the way we used to, because we're using I forgot the name of the reactive framework that we're using now in Java, but we're using a reactive framework that is more or less handling all of that for us. So again, it's enabled us to hand off more of the complexity in these parts of the application and focus more on the things that add value to our customers. So that's it for the third part of the architecture, or rather version 3 of the architecture. As you can see from there, we've still kept things like Lucene in some form, because we've moved from using Lucene directly to using Solr. We evaluated Elasticsearch a number of years ago, and we decided to use Lucene long before we started using Ignite, and we've gone for Solr as we went from Lucene up to having an external server, because the calcite engine that we've got in place, when we're doing our queries and we need to check an index to see if that data has already been cached, then we'll hit Solr rather than Lucene, and if we rather than going directly to the data source. And if we'd kept Lucene, then we would effectively have to build a server on top of it, which would be a pointless venture to make when Solr and Elasticsearch have already done that. So the new architecture addresses those problems. Importantly, it addresses what might seem like a simple issue, but is very big for our customers. The nature of our customers, more non-technical ones, means that something that looks, you say, oh, you can't change the type from a string to an int. The first question they will ask is, but why? And some of them don't have the technical expertise to understand why that's an issue or why that is the way it is. And so it's not really optional for us not to support that. And that's why it's a key issue for the new architecture that we've introduced. And then the other part of this was the move to supporting all of these different sources and sinks and enabling them to be able to provide their own. Especially when we go on-premise, when we have on-premise deployments with our enterprise customers. Like, for example, we've gone into a couple of hospitals, and typically they all have like Oracle databases, things like their medications, the doctors and nurses already working there. They're all already in their Oracle database, and we can't ask them to move those. Well, they wouldn't in the first place. So we needed the ability to be able to quickly add support for additional sources and sinks and have those integrate into the platform and into the APIs that we provide to our customers seamlessly, as if it was just a natural part, a native part of the platform. We've retained the scalability. So in all of our tests so far, there's been no regression on performance. We're not finished implementing this yet, so it's still early to be able to really say that. But from what we've done so far, we're continuing to maintain below 100 milliseconds across the diverse types of queries that we need to support. The one-to-one mapping on the types, as I mentioned, is gone. The advanced indexing capabilities, though we've left Lucene, we've basically taken Solar, which has replaced that almost one-to-one. And at the center of all of this is Ignite. So right now, when you use if I go back one slide, when a query comes in and hits the calcite SQL facade, every actual piece of data that needs to be returned is in Ignite itself. So there's only the indexed data in Solar. We don't actually have any customer data in Solar. It's literally being used just as an index. And so once we actually need to grab the object, that needs to go back to the user, to the customer. That's actually being stored in Ignite itself. That's it. So I've come to the end of my presentation. Again, I'll remind everyone watching, the Ignite Summit is happening on November the 16th. So do sign up. If you have an interest in cloud use case, then submit those. The call for speakers is now open. Thank you, everyone. And I'll just say as well before I finish that we're currently hiring for a CRO and other roles. So if you're interested, then get in touch. My email address, courtney.robinson@hippie.io. Should I start with the first question we had?
Yeah, I've copied it here, so.
Okay. So the question is, do you run federated queries, a query that joins data from multiple sources with your calcite facade? You probably asked this before, but yeah, so we do. You can use any data source within your application that you've defined. So you could decide, for example, you're going to pull some data from Google Analytics and some data from what we've got in Ignite, and you can run a single query that uses both of them. And we use the calcite facade to be able to join and run your query across those. If you're interested in how we get that to be performant, I alluded to this earlier, but basically when the users define their data models, we take some information from them that tells us implicitly how we should do some indexing, but we also have like guided tours that allow them to be able to create custom indexing on these other data sources. And we can query, for example, we can query if you have a HTTP API, and you want to go to Google Analytics and fetch the data that you've got in there for the last, let's say, 5 years, and you want to run performant query on those. The platform can basically go through the API by paginating through as much as it allows, and then we will index all of this And if you tell us to, if I say us, if you tell the platform to, it will also store the data it fetches, not just indexes. It will store it in Ignite, so we don't have to go back to the external API. And then when you run future queries, instead of going to the external API, we'll just hit Solar and then we'll hit Ignite to pull that data out and return the response to you. If the API doesn't support pagination, then you can provide a custom implementation that would know how to get additional data out from it. But we can automatically paginate on some APIs.
Hi, Courtney. That's Dennis. I wanted to kind of ask you more questions, more like a little bit more about this federated queries and pagination you were talking about. Speaking about the federated queries, do you see like that capability useful for, let's say, real-time operations that need to stay, let's say, within the range of like milliseconds or seconds or more, or is it more about, let's say, analytical use cases when you need to cross query? What you see like when it comes to your to Hippie?
Mm-hmm. I haven't seen any real-time use cases that are doing that. Just trying to think. I think that the closest thing that I've seen to that was, I mentioned a hospital earlier. One of the enterprise customers that we have, they during COVID, they built an application on the platform that would notify nurses and other staff, and that was close to real time. So it was using the real time feature that I mentioned earlier. So if they migrated, once we've done V3, if they migrated over, that would have to use that capability. And they're using multiple data sources at the moment in the current architecture, but that was implemented manually to support their use case. So if they migrated, then that would be one use case where it would be more or less real time.
Mm-hmm. Okay, good to know. Yeah. It's just for you, like as a background, why I'm curious about all these federated queries capabilities when it comes to calcite. We had a discussion with some of our community members who are working actively on the calcite engine for Ignite right now. Mm-hmm. And we saw that calcite supports that federated queries ability. And the question was like, okay, if we enable this for Apache Ignite, what would be the primary use case? Will it work fine for, let's say?
So I haven't seen any use cases that I could use to describe that, but I can tell you what we're thinking about doing. So calcite has these windowing functions that you can use. And we have a lot of use cases, well, not us directly, but some of our customers have a lot of use cases where they're only interested in seeing like the most recent data that matches some query. And so the features that we're thinking of exposing under that will use the calcite window functions to just look at data over some period of time. And that period of time is usually, within the last minute, within the last 5 minutes.
Okay, got it. Thanks a lot.
No worries.
We've got a question in our chat. Please look here.
Yeah, okay. So any observations from using Ignite's native persistence for Ignite SQL will be helpful. So not in V3 that we're working on right now, but in the current architecture that's in production, we're using Ignite native persistence. In terms of insights, I don't know, without a more specific question, the only thing I can say is when you're using Ignite persistence, you need to be careful to make sure that you, I forgot the method, but we were incorrectly, I think, telling Ignite our cluster size. Every time a node joined the cluster, we were updating the baseline nodes. I can't remember the exact problem, but it was something like this. So every time a new node would join or leave, we were updating the baseline nodes. And we ended up a couple of times getting corrupted nodes because I really can't remember the use case. We realized what the problem was actually earlier this year when we attended Ignite Summit, and somebody else had this issue because they were doing the same problem. And in one of the sessions, I think it was the speaker or one of the panelists at the time said that you shouldn't be doing that. I can't remember the exact problem or the exact solution. I can't remember the methods off the top of my head, but I know that the problem we were having was that we would occasionally get nodes being corrupt, and we had to basically wipe that node and add it back into the cluster. And it was because we were incorrectly doing this thing every time a node was added or removed from the cluster. If you're interested in what that was exactly, I can do an email and send it afterwards, or I can send it on the mailing list to just put it out there. But I can't remember the exact details. It was something along those lines, though. I just recalled one other point you might want to think about with Ignite persistence. If you're using the data structures in Ignite, when you, I can't remember if it's the group that they're associated to, but all the data structures are assigned, or that their storage will be associated with the default group. And there's no way to change that at the moment in Ignite 2. That's one other caveat that just came to mind as you were explaining that.
Thank you.
If you're interested, then obviously reach out to me. You can also just take a look at our website. The no-code functionality on the marketplace I mentioned is coming in November. So if you are interested in that, then you can get in touch with me as well. And we can get you on the early access list for that. I think I've just found my notes about that issue. Sebastian, do we have time for me to quickly explain?
Yes, of course.
Yeah. So the issue I mentioned earlier was what we were doing was whenever a new node joined the cluster, we would add them to the baseline topology. And as they left, we would then remove them. So even if it was a restart because we were doing a release, an upgrade or something, we were always modifying the baseline topology. And then in Ignite Summit, the last Ignite Summit, I think it was Ilya that mentioned that we shouldn't be doing that because what we observed was basically, as I mentioned earlier, we would occasionally get a node that would have its data corrupted, and there was no apparent way to recover it. So we'd have to nuke that node and have it rejoin as a new node in the cluster. So what you should be doing instead is only update the baseline topology when all your nodes are online. And if one of them goes offline, if there's a restart or something else, you leave it as is. You don't remove them from the baseline topology. And that's something that wasn't obvious to us from the documentation or the APIs. And so we were doing the opposite, right? We were adding and removing them as stuff was happening. But you shouldn't be doing that when all your nodes, because obviously you know how many nodes you have in your cluster. If you have 3, 10, 20, whatever, you know what that number is. You only update the baseline topology once all your nodes are online, and then you leave it at that unless you're actually changing the cluster permanently. So that was in response to the question earlier about the using Ignite's native persistence for SQL. That's it, Evgenia.
Thanks. So we have no more questions, so I can say that we should, we can end these meetings. That was nice to meet you all, and I hope to meet you at the next events.
Well, thank you. Thanks everyone for coming. It's a pleasure to meet all of you. Until next time.